Hello students. In the earlier class, we have discussed about the exercise 1 from first chapter real numbers. Now, let us discuss about the solutions of exercise 2 from the first chapter real numbers. But before that, let us discuss about the definition of irrational numbers, which are more important now for the solutions of exercise 2. So, irrational numbers. Of course, we have many definitions for irrational numbers. So, first one is the numbers which cannot be written in the form of p by q. Pq belongs to z and q not equal to 0. Here z. Z stands for the set of integers. Next definition is if p is not a perfect square, then root p is irrational. Next one, if p is a prime number, then root p is irrational. So the second and third definitions will stand for the solution of exercise 2 here. So we can have some examples here. For second definition, root 8, root 6, etc. Because 8, 6, etc. are not perfect squares, so their square roots are irrational. Of course, we can take here if p is a prime, root 2, root 3, root 5 and so on. Of course, we can take root 2, root 3, root 8, root 5, root 6 and so on are irrational numbers here. So, if we understand, it will be very easy for us to prove that the given are irrational. So, they are important for 4 marks or 8 marks, even both in old syllabus and new syllabus. So, you understand well, and I hope you will do even you are given some different numbers in exam also. So, all the best. In exercise 1.2, the first question is prove that root 5 is irrational. So we know that 5 is a prime number, then automatically root 5 is irrational according to the definition of irrational numbers. But we need a proof for the academic purpose. So here let us assume that root 5 is a rational number, and in the latter steps we will come to a conclusion that our assumption is wrong, and again we will declare that root 5 is irrational, and this is called as the method of contradiction. So let us start. So let us assume that root 5 is a rational number. Of course, we know that a rational number can be written as a by b or p by q, whatever may be of letters in the form of a fraction. If you observe theorem 1.3 for proof of root 2 is irrational, we have a lot of steps, but in order to avoid some confusion, I want to write some specific steps. Of course, they will also fetch full marks in the examination. So I am starting. Root 5 equal to a by b, because we have assumed that root 5 is a rational number. So here root 5 equal to a by b, where a and b are co-primes. That means a and b are having no other common factor than 1. So of course I already told that it is the method of contradiction. Root 5 equal to a by b, then b into root 5 equal to a. See here, there is a lot of difference in writing like this. It makes a bth root of 5 equal to a. So better to write in a neat form while attempting the questions in examinations. So writing this form is wrong and this is right. I have to remember that. Next, squaring on both sides. So here b square into root 5 whole square equal to a square. Square will get cancelled. We will get 5b square equal to a square. Here, this one follows the exponential formula that ab whole power m equal to a power m b power m. So it is better to have the knowledge of exponential formula and special products and a lot more. It will be easy to use them whenever required. So 5b square equal to a square. That means a square is the product of 5 and b square. That means 5 is a factor of a square, or 5 divides a square. 5 is a factor of a square. 5 is also a factor of a. Next, let a equal to 5c. So taking like this depends upon the number given inside the square root. Here I am given root 5, so I have taken 5. If I am given root 7, I will take here a equal to 7c like that. If I am given 3, that means root 3, I had to take. Yes, you are right. A equal to 3c. Therefore, here let a equal to 5c. Therefore, 5b square equal to 5c whole square is equal to 25 c square. Again, the formula ab whole power m equal to a power m into b power m. So here b square equal to 25 c square by 5, which is equal to 5c square. That is 5 is a factor of b square. 5 is also a factor of b. See here, in the previous case, 5 is a factor of a, and now we have stated that 5 is also a factor of b. That means a and b are having common factors. Let us discuss in detail. Therefore, 5 is a common factor of a and b. A common factor of a and b. It contradicts the assumption, our assumption that a and b are co-primes. A and b are co-primes. That means it contradicts the assumption that root 5 is a rational number, because I have written root 5 equal to a by b. Therefore, our assumption is wrong. Therefore, root 5 is irrational, or root 5 is an irrational number. So it is important for public examinations, and of course it is important for 8 marks in general. So like this we can prove it by the method of contradiction. Second question, prove that 3 plus 2 root 5 is irrational. So as usual, for this all proofs will of the method of contradiction. Let 3 plus 2 root 5 is rational. That means 3 plus 2 root 5 can be written in the form of a by b, where b not equal to 0. That means in the form of a fraction. Here 3 is adding 2 root 5, it moves to right side of equality, it subtracts a by b. 2 root 5 equal to a by b minus 3 equal to a minus 3b by b. Now on the LHS side, 2 is multiplying root 5, it moves to right side. It divides a minus 3b by b. So let us see. Root 5 equal to a minus 3b by 2b. So if we observe, a, b are rational numbers. So RHS part, a minus 3b by 2b, a minus 3b by 2b is rational. Therefore, LHS part root 5 is also rational. But it contradicts the fact that root 5 is irrational. So root 5 is already irrational from the definition of irrational numbers. Therefore, our assumption is wrong. Therefore, 3 plus 2 root 5 is irrational. So, what is the name of the method we have used? The name of the method is the method of contradiction. So here, name of the method of proof is the method of contradiction. So it is also important for 8 marks. So now, third question. Prove that the following are irrationals. In that we have first one is 1 by root 2. We have to prove 1 by root 2 be irrational. So by seeing root 2 in denominator, we need not get confused. It's very easy to prove. And of course, it may come for even 8 marks. So here, we will prove this by the method of contradiction. The method of contradiction. Let 1 by root 2 be rational. Therefore, 1 by root 2 can be written as a by b, where a and b are co-primes. So, here what to do? Just see here, by taking reciprocals. 1 by root 2 can be written as root 2 by 1 or root 2. Root 2 equal to b by a. It is written by taking reciprocals. A and B are co-primes, so here it makes no sense that A by B or B by A may be of any form. Once A, B are co-primes, then they exist to be co-primes. RHS B by A. RHS equal to B by A is rational because AB are co-primes, so automatically the RHS part is rational. Therefore, LHS part root 2 also becomes rational. If RHS part is rational, then LHS part cannot be rational. It has to become rational, but it contradicts the fact that root 2 is irrational. By the definition of irrational numbers, root 2 is irrational. That means our assumption is wrong. Therefore, 1 by root 2 is irrational. See, even though root 2 is in denominator for the question 1 by root 2, its proof is very easy when compared to the proof of root 2. It is given as theorem 1.3 in the textbook. Prove that root 2 is irrational is given. Its proof is a little bit wider and somehow little bit confusing, but see this 1 by root 2. The proof of 1 by root 2 is irrational is very, very simple. If it comes to exam, it will be a lucky thing for us. So in third Roman, the second question is 7 root 5. By the method of contradiction, let 7 root 5 be rational. Therefore, 7 root 5 can be written as the form a by b, where a comma b are co-primes relatively prime numbers, and many more names are there. You just have a look at my videos in the previous case about prime numbers. Therefore, root 5 equal to a by 7b. Now let us go to RHS part. RHS equal to a by 7b. A, B are of course being co-primes, they are rational, and 7 also being rational. A by 7b is a rational number. Automatically, LHS equal to root 5 is also rational, because when RHS is rational, LHS cannot be rational, it must be a rational number. But it contradicts the fact that root 5 is irrational by the definition of irrational numbers. Therefore, our assumption is wrong. Therefore, 7 root 5 is irrational by the method of contradiction. And I have already told you that while writing like this, one must be very careful. There is a lot of difference in writing 7 root 5 means 7 into root 5, and like this 7 in the root of 5, 7th root of 5. It makes a lot of difference For this context, 7 root 5 is correct. This is writing like this is wrong. So I have to take care of writing symbols while answering. Now let us solve third question in third Roman, that is 6 plus root 2. Prove that 6 plus root 2 is irrational. So for that, as usual, we have the method of contradiction. By the method of contradiction, let 6 plus root 2 be rational. Therefore, 6 plus root 2 can be written in the form of a by b, where a and b are co-primes. 6 adding root 2 on left side, if it moves to right side, it subtracts a by b. So root 2 equal to a by b minus 6. So here a minus 6b by b on RHS. So root 2 can be written as now a minus 6b by b. So here RHS part a minus 6b by b, and of course if you are able to write this entire thing again, you write. If you think you get confused, you just write RHS and LHS. It makes no problem, but you have to use the correct usage of words and sentences. So it must be correct in technical. So RHS is equal to a minus 6b by b is rational because a, b are rational and 6 also rational. So a minus 6b by b is rational. Therefore, LHS equal to root 2 also becomes rational. It is inevitable because when RHS is rational, LHS cannot resist. It has to be a rational number. But LHS we have is root 2. But root 2 is irrational. But root 2 is irrational, and it contradicts our assumption. Therefore, our assumption is wrong. Therefore, 6 plus root 2 is rational, and it is the end of the second exercise, and of course the end of the chapter and this chapter. First chapter real numbers is one of the easiest chapters in the syllabus. So it is better to learn each and every problem of real numbers and try to get good marks.